we have a pair of parametric equations, and maybe they describe a curve that looks a little bit like this. We're interested in a point on the curve, 14, 1, and particularly the normal at that point. So the tangent would look a little bit like that, and the normal would then be at right angles, and then we want to find out where the normal meets the curve again. So in this case it would be here and here, and we'd be interested in working out what that is. So first things first, we're going to need to work out the gradient of the curve. The reason being that the tangent has the same gradient as the curve at the point 14, 1. So let's work out dy by dx. And that's going to be dy by dt, dt by dx using the chain rule, or you might go straight to writing dy by dt all over dx by dt. Sorry, dy, that should have been a t. Dy by dt is minus 4t. Dx by dt is going to be 15 minus 3t squared. So now we need to look at this point when x is equal to 14, y is equal to 1, and we need to find the value of t because we want the gradient of this red curve, this tangent. We can do that by substituting in, so we're going to get that 14 is equal to 15t minus t cubed. And we could try and solve that for t, but it's a bit awkward because it's a cubic. So let's go for the other one. 1 is equal to 3 minus 2t squared. Sorry, got the wrong way around. Okay, so I can manipulate this, so it's going to be 2t squared is equal to 2. T squared is equal to 1. T equals plus or minus 1. That's all well and good, but now we just need to check, or not in this one. Okay, just because we have two solutions here doesn't mean it will also work in the other equation. So t equals 1 gives 14 equals 15 minus 1. This is good. T equals minus 1 gives 14 equals minus 15 minus 1. There's no way that's going to work. So basically t equals 1 at 14, 1. Okay. So where are we up to? We've worked out the gradient of the curve. We've just worked out the value of t at the point that we're interested in. So now we can work out the gradient of the tangent at that point. A lot going on here. So we can substitute 1 into here. So it's minus 4 all over 15 minus 3. Minus 4 over 12, or minus a third. And the gradient of the normal is in a negative reciprocal, it's just 3. equation of the normal then. Okay, this is the key thing we're trying to get to, because if we can get the equation of the normal, we can solve it simultaneously with the equation of the curve to work out the other point of intersection. Y minus y1 is mx minus x1. That tends to be the easiest formula to use for the equation of a straight line. And we have that, remember that it's going through 14, 1. So it's y minus 1 is equal to 3, x minus 14. Okay, that's quite a good step. So we have the equation of the normal, and we have these, the equation of my curve. And I'm interested in when they are the same. So what we can do is the same kind of thing as when we solve, I don't know, simultaneous quadratic equations. We can substitute in for x and y. So because I know y equals 3x minus 41, I can substitute the equation of my curve, the y1 into here, and my x1 into here. So when normal intersects C, I've got 3 minus 2t squared is equal to 3 lots of x, which is 15t minus t cubed, minus 41. Okay, and we just tidied this up, so we're going to get 3t cubed. I'm going to get that onto the left and make it the coefficient positive, minus 2t squared, minus 45t, and then it's going to be 3 plus 41, so plus 44 equals 0. And we've got ourselves a cubic to solve. Not a very nice cubic, but here's the thing. T minus 1 is a factor since we know that t equals 1 is a root. We already know a point at which C intersects the normal, or they intersect each other. We did that earlier, remember, so t is equal to 1. We use the factor theorem to get that t minus 1 is a factor. Maybe I should just write it down. So now we can work out, we can basically divide by that, because we're aiming to factorize this cubic. So I'm going to do polynomial division. Okay, t's into 3t squared gives me 3t, cubed gives me 3t squared. Plus t Okay, brilliant. These subtract to give 0 as expected. So therefore, t minus 1, this thing, equals 0. I would expect this to factorize. If it does, it's got to be 3t and t. Now we need it such that when we put the numbers in, they're going to be quite close. So maybe 11 and 4, yep, that's going to work. So if I put 11 here and 4 here, I did that quickly because I could see that, yeah, 3 times 4 is 12, 11 times 1 is 11. I can easily get my plus t. So which one do I need to make? This one positive to give me 12t, and this one negative to give me minus 11t. And therefore t is equal to 11 over 3 or minus 4. So those are the other two. In this case, there are 2 other points of intersection. And that is everything we have to do. Find the values. I didn't actually spot that, but yeah, that's good. Find the values of t at the points where the normal to C at 14.1 cuts C again. So I wouldn't include the t equals 1 because we've already dealt with that. But that's our answer.